Hi, everyone. Great to see you here. Excited that we're all back together for another SmartCon after such a great year of building Chainlink and the verifiable web and the Web3-powered future. I think the thing that it might be useful for us to discuss is exactly what it is we're actually involved in building here and how it can help change the world in the right direction before we get into the details. When I look around, I see a few things that concern me, that I think the technology that we're building can genuinely solve. So the first thing is that there is an immense amount of manipulation going on in every aspect of society. Basically, in the financial world, you see everyone being manipulated by both institutions and now smaller groups. In the world of information, very few people can rely on the news or the information that's provided to them. And generally speaking, with the appearance of AI, I think we're unfortunately going to see even more manipulation, even by certain individuals that have access to extremely powerful computing systems. So this world of manipulation is something that, unfortunately for us, is increasing. The good news is we have technology to solve it. So the way that I see manipulated systems being solved is that they're user-controlled systems. So they're systems that users have the ability to verify what the system is before they join. They have the ability to know what's going on in the system in a verified way. And they have the ability to leave the system whenever they want, after they've verified what's going on. This is not something that I think we have today, and I think it's going to be increasingly more important as more and more of the world's systems become manipulated. The second aspect of creating this manipulation-resistant world is really information. Because if you can't get the right information about the system you're about to join, if you can't get the information about what's going on in the system, you can't understand, A, what you're signing up for, and B, how it's going. So basically, unverifiable misinformation, I feel, is the second big problem. Because without verifiable information, you can't understand what's going on, basically. What both of these things of manipulated systems and unverifiable misinformation lead to today are reactive fixes. So basically, we go into a world where something goes wrong, a bunch of people complain, a bunch of other people make some excuses, a largely inadequate fix is proposed, an even worse version of that fix is implemented, and it all happens again. That's the story of the global financial system, most recently with things like SVB, even though we had the 2008 financial crisis. That's the story of multiple news cycles that are proven to be basically false information. And at the end of the day, we arrive at a place where we see a problem, we run to fix it, we don't fix it, and it recurs. The world that I think I would like to live in, and probably most of you would like to live in, is a world where I can know what every system is going to do for me before I enter the system. I really don't care if it's a financial system, if it's an informational system, if it's any kind of system connected to me or any kind of value related to me. It's really any system. I want to know what I'm getting into before I enter the system. The conditions under which I can leave, the deterministic guaranteed promises of the system, and how those work. Then I need to know what is going on an ongoing basis. I need to be able to verify what is going on in the system. This is where verifiable cryptographic truth comes in, and through cryptographic truth, we can know what the system is doing. That will lead us to make a choice about whether to vote with our feet. This is really the most fundamental choice of everybody. It's their choice about staying in a country, it's their choice about staying in a system, it's their choice about where to put their money. And this is the choice that I think has gradually been taken away. So these are really the three properties that I think we want to get to people in every aspect of their life. We want them to be able to verify the systems they're getting into and how those systems work and what they do and don't do. We want them to be able to proactively verify what the system is actually doing with their money. For example, is the money in my bank account at a bank at risk because the bank decides to use it for things that put it at risk? That's an interesting question that before SVB, many people wouldn't have asked, but after SVB, many people do ask. And unfortunately, the answer is in many cases not very good. So we're going to continue to see these types of problems. And then when there are failures, or when something does go wrong, or when the system isn't operating the way you expect, you should have the choice to leave, if that's what the system promised you when you entered it, which you should be able to clearly verify. So this is, at a high level, the world that I feel we're working towards by making blockchains, smart contracts, oracle networks, trust-minimized computing, decentralized computation, all these wonderful concepts, for me, roll up into this world. So let's look at three very immediate near-term examples about how this change in the world will impact us. The first one, I think, is the financial system. So the financial system currently works through this reactive mode where people manipulate information to make promises or cook the books or claim they have assets of a certain value but not of another value, or any number of other interesting and confusing methods that basically lead to the same result, that it wasn't what people thought it was, basically. And people were unable to verify what it was because that information isn't available to them, it's not within their control, it's not verifiable, and then once the problem happens, everyone gets a nice surprise that basically says, you can't leave. Sorry, you don't have private keys here, you're in our database, and we're just going to keep you in our database, and you're here now with us as everything implodes. So, that's not exactly a great situation. So how do we, in this very specific example, which throughout my life and your lives I think has recurred more than enough times, how do we get to a better manipulation-resistant, verifiable web world? The examples here all actually have the same answer, whether it's energy markets in Enron, whether it's the derivatives industry in Lehman, or whether it's even basic banking operations like lending through SVB, it's always the same answer. It's you combine blockchains, blockchain networks with oracle networks to create verifiable applications. Those verifiable applications make cryptographically guaranteed representations about how they work. People independently verify those representations by looking at the math and looking at the code and looking at how the application actually works. And then they make a choice to enter these other systems. One of the ways that this can all be done, actually, is through multiple interfaces. So you should be able to enter these different back-end systems that are a combination of blockchain networks and oracle networks through multiple different interfaces, so that if somebody wants to turn off your access through one interface, you can just switch to another interface because you fundamentally control the ability to join those networks or leave those networks, not the interface. This, I think, would solve a large amount of problems. Firstly, everyone who's in the system would know what they're entering when they do business or put their value in one of these organizations. Secondly, everyone would know at the same speed as the people in the organization about what's going on with their value. And third of all, if they didn't like what they saw, they could leave, which actually I think will create even more personal accountability for people, where they cannot say that some system took something away from them, and it'll get us out of this ridiculous cycle where we print money to bail out people that took risk that no one signed up for, which is not a very sustainable model for really anyone. I have frankly no idea how it's gotten to this point. Great, thank you. I think that means you agree. Great, glad to hear it. The second big category that the verifiable web can have a big impact on is developing economies. So developing economies often don't have certain levels of legal frameworks or legal systems, or basically the law, to allow them to generate these four things. So if you're in certain developing economies, you may not have a bank account, you may not have insurance, you may not have the ability to sell globally, and you may not have the ability to receive direct investment, basically any kind of investment for others. If you look at these four things, these are basically the ingredients to people's economic future. You need the ability to save money in a way that's stable and under your control and not under the control of others, that they can keep it from you. You need an ability to manage risk through insurance so that if risk happens, you don't lose everything. You need an ability to participate in the global marketplace directly without middlemen taking all the value that you create. and you need the ability for people to invest in you if you provide real value. These are things we all take for granted, but they don't exist for billions of people in places where the legal system doesn't allow one or more multiple of these things. If we create, and as we are creating, a system that creates the verifiable web and a parallel system of contracts, people can have stable coins in their bank accounts. If they don't want stable coins, they can have gold coins that are backed by real gold that's proven to exist. They can have smart contract insurance that manages risk for them, even better than the insurance in developed economies, where once again you have brands that can just not follow through. You can give them access directly to the public global marketplace by them proving things about themselves in ways that don't require middlemen that take most of the value they create. And then if somebody wants to give them money, they can give them money because they can receive a token in return. And the token has nothing to do with a legal system. It's a completely technically guaranteed form of ownership. So this is the second thing that I think a verifiable web and our work in this industry will create, is the ability to take the developing countries, emerging markets, to a place where they have a working legal system, which for me, practically speaking, means these things. This will be very similar to how many of these economies went from not having landlines to everyone having a mobile phone, basically, eventually an internet-connected mobile phone that was so good that they also leapfrogged into a world where even if they didn't have paper libraries, they're now able to read the same information that you and me can read on Wikipedia. So this leapfrogging of technology changing the way the world works, I think is most prevalent in these parts of the world. And I think that creating a verifiable web and creating an internet of contracts will allow this to emerge. And when I look at what telecommunications has done for people to be able to communicate, and when I look at what the internet has done for them to be able to be basically informed and educated, I think this will do for the speed at which economic prosperity happens in these places, because these are four critical building blocks without which it's very hard to create real economic growth and prosperity. The final thing that I think a verifiable web and an internet of contracts should solve for us, or at least make a lot better, is the issue of information transfer, basically. So all of us are now in a world where we cannot trust the news. We cannot trust the information transmitted to us through the news. We cannot trust the information transmitted over social media. The majority of the public, just average people, not even the moderately to very paranoid people at this conference, but this is a survey of the, what do we call normal people? I don't know. The normal people. I hope that's good. The good normal people out there are like basically now also saying this is, how bad do things need to get, right, for that to be a thing? So it's not good, right? Basically, everybody is now understanding that the entities and the systems meant to give you information are not going to give you information. They're going to try to manipulate you towards some set of goals, economic or political or others, which really is kind of not a good thing when you think about two things. That first of all, people need to be informed to make decisions. And secondly, this wonderful AI thing is unfortunately not going to make this problem simpler. It's going to make it a lot more difficult, because now, with even relatively limited resources, you can manipulate growing groups of people to do I don't know what. We'll see, I guess. So this is the third problem that I think affects all of us, regardless of what part of the world you're in. And for this, I think we can create certain basic cryptographically proven ground truths. These ground truths can be verified by computers and cryptographically signed in a way that no one can dispute them, because you can, first of all, see the source that was used to create the ground truth. You can see how the ground truth was created. You have proof that the ground truth was created by people signing things in a certain way. And then if someone doesn't like that version of the ground truth, they can propose a new one and generate that in a verifiable way. I also think this will help partly solve the problem with AI, because if we don't have some basic ground truths on which to stand, we will not only not be able to communicate with each other to make decisions, as is partly the case now, but we will be able to be convinced by AIs of really wacky stuff And so having a certain cryptographically proven set of ground truths, I think, will end up becoming increasingly useful and valuable. So this is kind of how we started looking at this problem in our work on the Chainlink network. So we worked on cryptographic truth, which I felt was, I didn't kind of realize it when we started, but as I thought about it more, both on the history of how truth interacts with various different technical systems, and actually how truth powers different aspects of society, I kind of realized that we are part of a pretty unique and important tradition, because society has generally been powered by what people consider to be true. So initially, I think society was, a lot of things in society were determined by the stories, which were turned into myths. Then there were these kind of agreed upon versions of reality called religions, and that is what, you know, determined a lot of how society functioned. Then you began to be able to measure things, and repeatably and provably measure things. And once you began to be able to measure, you know, that the earth is round, or that the sun is there, and, you know, like all these things can be replicated by anybody at their own pace or in their own way, you kind of had scientific truth emerge, right? So scientific truth then became the way that society functioned. It's what it moved towards, because that was viewed as a clearer, better form of truth, at least for most people, even though I think those things can coexist, but that's a different question. In any case, the next stage was the transition of printed into digital truth. Printed truth was kind of nice when you had the Gutenberg printing press, and there wasn't a lot of printed truth, and so it was kind of hard to make it, and, you know, you weren't overwhelmed with information, and, you know, people would write relatively intelligent things. And then it became digital truth, and here we are, basically reading God knows what from who knows who, and now it's actually a computer pretending to be a dog, but no, it's really a computer. I don't even know, like, what's next. So basically, at this point, I'd probably rather take a dog than the computer. I'm not even sure. In any case, the digital truth is now where we are, or it's where we were in the last 20, 30 years. Then we moved on to computational truth, where computers continually told us what the truth is by combining information and doing analysis. And now I think we're kind of at this crossroads of computers becoming very powerful and being able to tell us all kinds of computational truth that might not be true. Kind of defeats the purpose. And then you have cryptographic truth, which you should be able to verify, right? So cryptographic truth might not be able to give you the answer to every single question, but it's something that you can verify as being on a solid foundation. You know where it's coming from, you know how it's composed, and you know that it is immune to manipulation. So this is the initial body of work that we were working through when working on Chainlink. The first thing that we did really was provide market data. Right now, the Chainlink network has provided the most cryptographic truth, I think, in history, in the form primarily of various market data, price data, and asset-related data, because that was the data that was in demand to create DeFi. So basically, there was a lot of demand for various market data that can't be manipulated. Because there was that immense demand for market data that can't be manipulated, we kind of arrived at a world where that was the data generated, because it's like a cycle between demand and supply. But I think there's all kinds of other cryptographic truth that we already generate and will continue to generate. This cryptographic truth that we generated initially in the form of market data and asset data is clearly something quite valuable to people, because it has enabled over $8.6 trillion in transaction value. And this is only counting less than the last 2 years. So this is only last year and whatever has gone on this year. So that's a lot of transaction value for anything. So clearly there is real demand and real value in providing cryptographic truth, even in this very small subset for this relatively early part of the world, the DeFi world. We basically expanded the amount of cryptographic truth we provided from market data to proof of reserves, which we're the largest provider of as well, then to other types of data, identity data, weather data, all kinds of other data, basically trying to replicate the DeFi boom experience by creating the necessary data points that would allow those industries to emerge. That is basically what we've been doing for a number of years. Some of those industries have emerged, some of them haven't emerged, but nonetheless, I think they will emerge, and I think the data will be a critical factor. Another thing we realized along the way, though, is that data really isn't enough. If you want to build these verifiable applications where people know what they're getting into, know how the system works, and can leave at any time, you're basically in a place where you have to both provide verifiable data, provide verifiable computation, and provide verifiable connectivity. If any of these three break, then the verifiability, deterministic nature, cryptographic guarantees of the system break. Because you can get 2 out of 3 right, but it still won't work. So if you get data right, but computation is broken or false, or you can't verify it, then people can control the application through the computation. If you get data and computation right, and then you need to connect to other systems and other contracts and other blockchains, and the mechanism that connects you gets compromised or doesn't behave in the way that was promised to you, so your verification doesn't work the way you expected, then the system also breaks. So that is why we moved on to solving these 3 extremely large and important problems. The ability to ingest data, the ability to have verifiable, cryptographically guaranteed compute, and the ability to have verifiable, cryptographically guaranteed connections. This basically makes the Chainlink network, the Chainlink platform, the place to build these verifiable applications, because you get all 3 of these key building blocks. The thing that we've most recently launched for this is functions. Functions is something that should be coming out today into mainnet. It's the most advanced version so far of the combination of data with computation. In functions, what you can do is you can make an API request to any API that you can define, and then you can input your own arbitrary computation that you have defined into the same Oracle network. So there's a computation around the data, both of which you chose. This level of flexibility is something we haven't seen from Oracle networks before, and something that people need to be careful about using in the right, proper, secure way. But it's definitely the most advanced version, because now you can define the place where you get the data. You can actually define multiple places. And you can define the computation that you want done on the data. And this kind of more self-service, more flexible, more expansive way of building Oracle networks and verifiable applications is where we're generally going. So with the appearance of functions, we're now in a world where the Chainlink network and the Chainlink platform squarely provides both cryptographically verified data, cryptographic truth, and cryptographically trust-minimized compute across random numbers, automation to trigger contracts, and now functions to interact with external information and do computations around that external information in the same place. So I think that's great progress. I think functions is the second big thing coming out this year, in addition to CCIP, which already came out. And I think it's a lot of real progress, and it's increasingly advanced ways of making these applications. The next problem, as we mentioned, was cross-chain. Cross-chain is a monumental problem because it's basically the problem of creating the Internet of contracts. And it's not just creating a set of networking connections between different nodes or different systems. It's actually creating a set of connections that can secure trillions, and probably eventually hundreds of trillions of dollars in value, as well as the flow of information together with that value. So it's basically building the verifiable web by connecting all of the different blockchains, all of the different smart contracts in an efficient, secure, decentralized, and verifiable way. This final piece of the problem, I think, now that it's live and now that it's getting widely adopted, makes the Chainlink network and the Chainlink platform a place where you can go to make advanced verifiable applications, both from the data point of view, the compute point of view, and the cross-chain point of view. The thing we focused on with CCIP is really around both verifiability of what's going on and decentralization. Because the decentralization security model, I think, fundamentally works. Many of the people that have tried to solve this problem before today don't really generate the amount of security via decentralization that we think is needed, which actually was the exact same story with data oracles. So before decentralized Oracle networks were utilized to transmit data to DeFi, the story there was pretty similar to what we see in the bridge world, where there were a few centralized solutions or one or two people trying to combine something and make it seem decentralized when it's actually distributed. and basically creating massive risk and issues in a way that didn't allow DeFi to take off. So this is kind of a pattern we've seen before, and I think it's a pattern that the decentralized nature of Oracle networks can really help solve. This solution, the ability to have reliable cross-chain security, reliable cross-chain value transfer, reliable cross-chain communications, I think will create two fundamentally different worlds that will eventually combine. The first world is the public blockchain world. That's the world that many of you are very familiar with, you're a big part of, you're building in together with various Chainlink services and creating the early versions of the verifiable web. That world is well underway. CCIP is live on production in that world. Many people are adopting it, using it to both move value and send information, and combining the value with the information to efficiently trigger contracts. The real plan for CCIP, not to say that it's a secret, I think you've probably heard this plan before, but more accurately, the whole plan for CCIP is to have it adopted as the messaging and value transfer standard in public chains and the messaging and value transfer standard in the capital markets. So basically, all the banks and asset managers that have all the money. You get all of the applications that are able to move quickly and innovate and build exciting new versions of the world, and then you connect them with all the money that can use them, and I think you get a world where there's a lot of applications with a lot of usage over CCIP, basically. That's the world that we're working towards, and it can all actually work on the same messaging system. It's actually better if it does, because as the public blockchain folks adopt CCIP and the capital markets folks adopt CCIP, they'll both start to realize more and more that their way to transact and their way to interact with each other is through CCIP. That's kind of the final part of the plan, and then that will also have this immensely powerful effect of creating the world's largest liquidity layer. So the place where the most banks, the most apps, the most wallets, the most asset managers are connected with their users' value. From the point of view of capital markets, I think we in the Web3 world can just view each one of them as wallets. Just think about this: a bank has $1 trillion. It's a $1 trillion wallet. It's an asset manager. That's $5 trillion. It's a $5 trillion wallet used by, I don't know, 100,000 people. From the point of view of the protocols and the systems that are going to get that value, value's value. So I think whether it flows in through Web3 wallets or bank wallets or asset management wallets, A, we want it to flow into all of these applications, and B, it's a really big opportunity for someone to create a way for this Internet of Contracts to emerge in a secure, interconnected way. So that's why there's so much work with capital markets, basically. Capital markets has there's many more problems that CCIP can help with, but it has three fundamental problems that it solves in the near term. The first problem is connectivity to blockchains generally. So how do you connect your 40, 50, 30-year-old systems to blockchains without having to reinvent everything, which is not an attractive process. And frankly, after working with more of these banks and asset managers, if I had $100 billion sitting on some system and switching that over was a risk and no user asked me and there was no user benefit and there was no efficiency benefit, I would question it too, right? So it's kind of like a question of why am I switching off this? Okay, it's a 30-year technology, but I can kind of wrap around it and it can still work. And that's what banks have done for decades. They have some old technology that gets wrapped with like XML or SOAP or something, and then APIs wrap that, and then now we wrap that, basically. This is something I think we're well on the way to doing through our ability to collaborate and through the Chainlink network's security and the ease of use for existing systems. This is a principled design decision that I think the people building the Chainlink network have made to say, we want to be able to integrate with existing infrastructure. We don't want to replace it, we want to integrate. And I think that's a pretty wise move because existing infrastructure in certain ways does work, has hundreds of trillions of dollars on it, and very importantly, it already includes the ability to sign with private keys. If we can integrate with the existing infrastructure We do not need to get a private key in the hands of the people running banks. They have private keys. We just need them, basically like the hardware wallet problem that people face in Web3. They don't have that problem because they've been using private key signing devices for years. And so what we need to do is we need to find a way to get those private key signing devices to sign the transactions that we want to flow value into the blockchain world. That's really the challenge we have. It's not replacing everything. It's making everything that can securely interact with blockchains securely interact with blockchains. That's the real challenging problem, that if you solve it efficiently, you can get to the world working on blockchains quickly. So let's say you do solve the first problem and you get them to integrate through their existing systems, such as Swift and the messaging standard there. And then you're basically faced with the second problem. Second problem is every bank has its own chains. Frankly, every bank will have multiple chains. There'll be chains by asset class, then chains by asset class by geography, and then it'll even probably go down to specific assets. So we're talking about eventually hundreds of chains per bank, in my opinion. So then the question becomes, how do all of these chains connect to each other to generate the purchase of whatever's on the chain? From a bank's point of view, there's no point of making an asset if no one's going to buy it. So it's kind of a cyclical problem, right? If I'm not connected to my counterparties, if I make an asset and I'm not connected, I don't have purchasers. So why make an asset? So this is the cycle that we need to break. We need to basically connect everybody so that there is massive liquidity waiting to buy any asset issued by a bank. And then as those assets get issued, that liquidity can flow into those assets. And that will be what, for banks, success looks like, is they generated a real-world asset about fund tokenization or real estate tokenization or carbon credit tokenization or really whatever tokenization that they're good at. And then, $1 billion of it got bought. And there's clearly another $3 billion waiting to buy. That's what success looks like to banks. What we need to do as an infrastructure is we need to get all of them connected so that the liquidity between them can flow and make that cycle of success happen for the real-world assets that they're generating. That's really the second problem, is solving this liquidity problem. This problem not being solved has finally become clear to the banks. The previous thesis for the banks was, let's all have everyone join my chain. Well, actually, the first version of the world was there will be a big global chain. I was actually selling, that's what I was pitching them on for like years. And then because blockchains don't scale, I was wrong. So then their thesis switched to, I'm such a big person, I'm this big bank, everyone is going to come to my chain, right? Everyone's going to come to me. They made their own chains. No one came to really integrate. No one wants to be on their chain. It's not worth it, basically. And so now they're in a world where they realize that everyone's going to be on their own chain, and they want to transact with you, but they don't want to go to your chain. They just want to transact, right? It's kind of like email. I make an email address wherever I use email, and you have an email address wherever you use email. I don't need to register on your email system for me to communicate with you, right? That's basically the version of the world we're now finally, after so many years, entering, which is quite good because this interoperability need is actually now very clear. They now understand that without interoperability, there will be no global chain that they will transact on. There will be no magical reason why the whole world decides to integrate with their chain. And so now they're realizing how the world will work. It will be their chain, thousands of other chains, liquidity elsewhere, their assets on their kind of liquidity island is what they call it. I'm not sure why they keep calling them liquidity islands, but maybe they want to go on vacation or something, I don't know. But so it's these liquidity islands. And then the question is, how do you bridge that gap, right? How do you connect those places so that whatever you release in your world and your chain has a market, right? Because that's fundamentally what these banks are doing, is they're trying to create assets that markets will form around, and then they will be successful. And once that happens, my expectation is that the banks are very good at making assets and even better at making markets. And once the technical systems and rails are there, they are very good at that. So once they realize that there is money to be made through the roads that we're creating, they will get on the roads. And so this is my kind of expectation. The third big problem, which is also another principal design decision of the cross-chain interoperability protocol, is that you need to be able to combine value with instructions, value with messages. So I'll just paint for you a picture of how the world works today. So today, if you want to get an asset on another chain, you go to your wallet on the first chain, on the chain where you have the stable coin, or the real, whatever coin you want to trade. You take that coin out of your wallet, you put it in a bridge, you go to the bridge, you use the bridge, you go to the bridge on the other chain, you take the asset out of the bridge, you put it in the other wallet, you go to that wallet, and then you finally use the application, then you get back whatever you got from the application, you take it out of your wallet, you put it in the bridge, you send it back, you go to the other bridge, side of the bridge, you pop it out of there, and you put it in your wallet, and you're done. And that sounds and is a nightmare. So that's not what we want. What we've done is we've been able to condense all of that down to one transaction. So you can stay where you are, and you can go and deal with whatever asset you want to from where you are, right? You have a wallet? Great. You can say, take my stable coin, go to blockchain X, go to smart contract Y, execute function Z, and return the output back to me over CCIP. Great. That's one instruction you had to give, and then there's a system that executes that. This is really, I think, a big deal because it changes the way our industry works, and it also changes the way the global financial system works, where often information and value moved separately. Now they can move together, which means that when value reaches its destination, you have information about what happens. And you can even make it conditional, that I'll give you the value if you do what the information tells you to do. And then you can get to this T+0 atomic stuff. You can get all these wonderful new worlds. And you can get there without having to ever go on the other chain. That's a very important point, because once again, our goal is to create secure efficiency so that more people can integrate with more chains efficiently. And so I would say that this is really the third big problem. One attractive side effect for the real-world asset tokenization industry, which I think is going to start picking up even more, is the ability for the Chainlink network to not only inject all the information that's necessary to make a real-world asset, such as proof of reserves information, identity information, so you can actually sell an asset to a bank because without identity information, they won't buy it, price and NAV and various settlement data. So your first problem is really, how do I generate this real-world asset? How do I prove that the gold is there? How do I add identity so banks will buy it? How do I settle the value on a daily basis through the price or NAV or whatever other mechanism? The second problem, as we've discussed, is liquidity. I've made my wonderful asset on my wonderful chain, but no one came to my chain. How do I get people to buy the asset from my chain? I connect to this cross-chain interoperability thing, and it connects me to all the other people who can efficiently buy my asset, and they don't need to worry about my chain or my technology. They can just say, hey, I just want the asset, here's the money, give it back to me. And so now I have access to that liquidity, and there's a growing liquidity layer that I can join and get more access to more liquidity and purchasing power. Okay, great. So that's problem number 2. Problem number 3 is actually after you sell or you move the asset to the destination chain. So the real-world asset got exchanged for some stable coin, and now the real-world asset has moved somewhere else. It's moved to another chain. Well, it's a real-world asset, so it needs to stay updated. It needs to know the status of the gold. It might need to know some more identity data. It might need to know daily settlement price or NAV data so people can value the assets that they have. So your problem isn't just creating the asset. It isn't just moving the asset so that liquidity can gain access to it. It's actually also keeping that asset updated, whether it's on chain B, C, D, E, F, whatever chain it's on, so that it can remain what in the capital markets is known as a golden record, or what we commonly refer to as a single source of truth, or what people are going to be calling real-world assets. Basically, you need the superior tokenized asset to remain superior because it's connected back to the real world, regardless of what chain it happens to land on. And that's important because if I take it to another chain and it loses the ability to get that information, it's not such a real-world asset anymore. It's some kind of like surrogate promise that I don't really know what's going on with that asset. And so this is something that right now only the Chainlink network can provide because of the ability to provide the data as the largest provider of proof of reserves and price and identity and so on, and the ability to move the asset to other places, as well as the information related to the asset. So this is, I think, an important consequence of being able to move value with messages and basically solving all three of these problems. By the way, if you don't solve these three problems, real-world assets don't end up really working. Because as the asset moves to other places, it starts to break down and lose the kind of fidelity and the information that made it particularly valuable as a real-world asset. So far, this is developing in a slow to moderate pace, but that's much better than the pace of not at all. That was the capital markets before. So in speaking with the capital markets for many years, I think I am now seeing them have digital asset teams, dedicated teams of people. I'm seeing very senior managing directors that make a lot of money for the banks become heads of digital assets, and these people have a lot of internal political pull to make decisions because they're the ones who make the money for the bank. And I'm seeing that they are now increasingly eager to do real transactions regionally. So basically, there is still this problem of legal clarity and the ability to assign liability and the ability to assign legal responsibility and to clarify how legally binding settlement works. But that problem is actually also in the process of being figured out, and the CCIP system is built more and more with that in mind because it's an important requirement. In any case, what's going on now is regionally, you have US banks wanting to do transactions on blockchains with US banks. You have European banks wanting to do European banks because of their pilot regime for tokenization in the EU. And then you have banks in Asia in their local regions being willing to transact with other banks. So this is something I've never seen before. I've never seen banks on production say, let's do some transactions with other banks across our respective chains. So this is a completely new stage that is not the same movie as before. And this is what actually makes me very hopeful that we can create not only the public blockchain Internet of Contracts, which will grow at its own pace, but we can actually create the bank chain Internet of Contracts. I think we're in the early stages. I think there's still a ways to go, but I think there's very solid progress, and it's the right time to create a standard. We have experience in the Chainlink network of creating standards. I would say that Chainlink is the standard for providing data to DeFi. I would say we're the standard for a number of other things that the Chainlink networks do, things everywhere from certain types of compute to proof of reserves to other things. And so there already is a lot of experience in the Chainlink community for creating a standard. I think this is a pretty valuable standard. So I think we might want to... Great. Thank you very much. It's clear you like this idea. We're going to be moving ahead. Okay. Okay. I can tell the community likes this idea. I don't... Okay. All right. Thank you. I appreciate it. We're going to have a party. It'll be... thank you. I appreciate it. I'm not so used to it, but I appreciate it. It's a great sign. Don't get me wrong. Thank you very much. Yeah, so... I mean, the next stage with a standard is basically more people on a standard. It's not that complicated, logically speaking. Every additional bank, every additional asset manager, every additional Web3 wallet, every additional protocol is more value, more liquidity on the system, which then attracts others to join the system because there's more liquidity for them, right? And then they join, and that creates even more liquidity and more value, creating the largest global liquidity layer. So this is the next stage of this, and then what I think it'll result in is, once again, these two separate Internet of Contracts, the public blockchain Internet of Contracts, and the bank chain Internet of Contracts becoming one place. And this is really what success looks like, right? Because on the current version, on the internet, you don't know what database someone else uses. You don't care what technology they use, what AWS instance they're using, whether they use GCP or Azure to do their computation. Like, you don't know these things. And frankly, as long as the application works and gets all the data and provides you the value, you don't really need to know, right? It's not an important question for you. What is an important question is how you can create that internet, right? So how can you create something like TCP/IP so that we can all be running our own separate database technologies, our own separate computing technologies, and it can all be connected into one network where everybody can communicate, and in this case, because it's the Internet of Contracts, transfer value. So this is the place where I think this would ideally go. It's something we're working on very heavily, and I think it really completes, I would say, the final piece of the Chainlink platform puzzle, because now as a developer using the Chainlink system, you get more or less 90% plus of what you need to build a verifiable application. You choose whatever blockchain you want, you get the data, you get the compute, and you get the connectivity to the users and the value that will use your application. So once you have these three things, you can create an environment and a community and a place where people who want to build applications, they can actually stay in the Chainlink network and the Chainlink platform across multiple chains. So they can be actual users of multiple chains, but what they're using across all of those chains is the same Chainlink DONs for data, for compute, and for the cross-chain connectivity, which will actually, I think, increase their usage of multiple different chains for that same developer. The next thing that we need to solve, in addition to creating all of these great low-level systems and protocols and making them secure and making sure that they meet the user requirements of these various users, both public chains and bank chains, is the ability to efficiently use the system, right? To efficiently interact with the system, pay value into it, gain access to more Oracle networks, and have stakers join and be a valuable security mechanism in the system. So this is why we are working on a payment abstraction layer. The payment abstraction layer is something that will abstract away the complexity of paying for Oracle networks while allowing Oracle networks to end up getting paid in Link that they can then use or keep for staking. So the payment abstraction layer is actually something that I'm not sure that many people in our industry can even build, because you need to know the value of the token you're getting paid in order to receive it. And in order to know the value of the token being put into a payment abstraction system, you need price oracles. And I think you know who has the price oracles, right? So I actually think this is the right way for payments to work for many different infrastructures and applications in our industry, and I wouldn't be surprised if this becomes its own separate Chainlink service that uses the data oracles to basically assign value to whatever token someone wants to pay in. So you should be able to show up and pay from a credit card, from a bank account, from your own coin that you generated in your own treasury, from the native token of the blockchain, from a stable coin, and that should then be taken into a payment abstraction layer, and then the payment abstraction layer can turn that into Link. The more important thing is really the reduction in friction. So our goal with the Chainlink network is not only to provide these highly reliable, highly secure systems and services, it is to get the network effect of the security going, right? And it's already going quite well, but it just needs to accelerate even more. So the more value and payments paid into the system, the more value can go towards creating more secure networks, more versions of the system that are increasingly secure. So reducing the friction that people need to go through to pay for getting the centralized Oracle networks should, very logically on simple basic economic terms, less friction, more payment. More payment, more value into the system, more value into the system to pay for greater security. Paying for greater security means you have greater security. And security is very important when everybody else is getting hacked left and right, and your system continues to remain secure. So in that sense, the payment abstraction layer that we are working on now and working through that to make it as efficient and basically as usable as possible, at least in the later versions, in the early versions, I think it'll be a lot of progress. That is one big initiative that's ongoing and underway now. There are already other ways and systems and programs for how people are able to pay for the security created by the Oracle networks. Build is a great example. That has grown to over 70 projects. And because Oracle networks are expensive, I think it's great that we have a way for smaller teams that don't have huge amounts of fiat, but want the greater security of high-quality Oracle networks to be able to allocate a portion of their token supply for attaining access to those secure Oracle networks. So this program, I think, is growing very rapidly. It's something I'm personally very excited about. And it provides a path for teams without huge amounts of fiat to gain access to really high-quality Oracle networks and prove to their users that they're secure, even though they're in the early stage of the creation of their system. And we've always been very proud of our work with many of the early DeFi protocols, and I think this gives us a way to continue it while still giving large amounts of security to great early projects. The second big initiative is basically the staking system. The staking system is able to include more and more participants in the security of the protocol, namely through stakers. And that is a system that is continuing to develop, continuing to improve. Today, we are able to launch the early access eligibility app for 0.2. 0.2 is underway and undergoing various security reviews, but it is basically something that we at this point think should be able to come out this year, and something that you can now check your early access eligibility for. It's something that we take seriously. The security of this is always important. And the goal here is to increase the security of the protocol, include more members of the community in the staking part of the system. Great. This is my new method, by the way. CCIP and staking. You guys like that. Got it. This is, I need to get like Twitter analytics or something. I still don't know how that works, but like, this is my system for now. Very old school, kind of how many times do people clap about things? Just one time we clap. Okay, good. I know the priority. Thank you. You said it, not me. Okay, great. The final thing that I think is a pretty important long-term goal, and something that will take years to really complete and get into the right place, similarly to how CCIP took a long time to get to a secure, usable place where high-quality institutions in the banking and capital markets world, as well as great technically savvy startups, are willing to adopt it. But I think it's worth it because it's a very good long-term model for people to efficiently use Oracle networks, is the decentralized computing marketplace, what we are at least internally calling the DCM. So the decentralized computing market should make it very simple for users from the banking world, from the Web 2 world, or from the Web 3 world to define their budget for security, to send that budget into a globally accessible market, on-chain market, and for that market to match their specific budget to the amount of security and the amount of data and the amount of compute that they can afford. Because one of the problems right now is the ability for people without a sufficiently large budget to afford the level of security provided by the Chainlink network, because the level of security in many cases is immense. So we need to make a system where not only do we make it easier for people to pay value into the system, but also for anybody of any budget and any set of configurations to define an Oracle network and receive that Oracle network back from a highly automated system that basically makes it reliable to the level that they are willing to pay. And in this way, you can basically meet everybody's security requirements and budget requirements. And what we've seen consistently is that as applications secure more value, their budget grows, because there's more at stake, and there's more at risk, and there's more to secure, and likewise, they're willing to pay for additional nodes, additional data sources, additional security. And so the decentralized computing market should be a very efficient, automated way to scale that security by matching it with the budget that people have to pay for it. This is something that's already underway, we're working through, and I think one of the main things it'll do is it'll weave all of the different Chainlink decentralized Oracle network services together into one great developer experience where you can build verifiable applications. So one of the great benefits of having all the data, all the compute, and all the cross-chain connectivity in a single platform is you can make a place where people can compose all of that all at once. So this means that developers will be able to show up, configure how many nodes they want in a DON, configure the triggers under which the DON acts, configures the places the data is fetched from and what to do with that data, and then configure how that data flows onto their existing chain where the contract is, and onto other places where that data is necessary, or affect the movement of value and assets. So generally speaking, this is really, I think, the medium-term state of the Chainlink network. I think the medium-term state is we have all of this demand that's been aggregated in the Chainlink network so far. I would say that of all the types of computations that we do, whether they're data-related or compute-related or cross-chain-related, we have, for the majority of them, the largest aggregation of demand. So there is basically the most demand in one place. The reason that's very important is because the challenge with making any market is getting the demand. Supply generally follows demand. The sell side follows the buy side. Basically, once you have developers that use a tool like this with a decentralized computing market on the back end to efficiently create hundreds or thousands of Oracle networks to power their advanced applications, you take the current demand that you have, you put it into a market and a developer experience like this, and now your system, the Chainlink system, is the greatest aggregation of basically developers and users, or developers as a proxy for the value that users are willing to pay them for their application in one place. And this means that all the best nodes, all the best data sources, all the best compute platforms will want to connect, as they already do, as you can tell from the great quality of our nodes and the continual addition of more data and compute platforms. So this is what I think will really accelerate us towards a more advanced version of the verifiable web. It's the ability to give developers a way to build more advanced applications quickly, to aggregate all that developer demand into a single market, and to have that market be the place where all the best node operators, all the best data sources, all the best compute resources go to be combined into this superior form of doing decentralized computing in the form of an Oracle network. And then those Oracle networks are combined with various blockchains to make these verifiable applications. And the verifiable applications, as we said at the beginning, have these wonderful properties where you know the system you're getting into, you know what's going on in the system, and you have the ability to leave at any time according to the conditions of the system which you initially verified. And so this is, I think, really where we'll be in the medium term. In the long term, we'll see. This industry evolves very quickly. But I think that we are eagerly now working on the payment abstraction layer and the ability for it to create a universal gas token and a unified universal payments layer, which I think will be a powerful thing. Our ability to create a good staking system, and eventually the ability to create a great decentralized computing market with a single unified developer experience where you can compose really advanced verifiable applications. I'm extremely grateful to all the people. Okay. This one? Just so I can keep it straight, this is for the, you're clapping for this or for the thank you? For this? Okay, fine. Okay. So this got 2 claps. So the 3 CCIP by 3, this had 2, and then this. Okay, I got it. Makes sense. Remember, you decided, not me. There you go. So I'm really very grateful to all the people who I've been working with for many years, both in the community and Chainlink Labs. Everyone from the node operators, to the developers, to the users that give us feedback, to the data sources, to everybody in the community who contributes to the success and growth of Chainlink. I know it's actually a huge amount of work and many late nights and many sacrifices to build something like this. And I think we are still going down the road, so we're all going to make, I think, more sacrifices, and there's going to be more work. But I think there aren't that many things in life that you could work on that are really worth it. And the more that I look at what we're building, and that we're building this single internet of contracts and the verifiable web and all of these new ways for the world to work, the more convinced I am that it is worth it. And for those of you that feel the same way and push yourselves to the limit and do whatever you can to help make us successful, I really, really deeply appreciate it. You know who you are. I don't know all of you in person and by name because now there's many of you, but I want you all to know that I'm deeply, deeply grateful for the amount of work that it takes to make a system like this work, and that it takes a huge amount of people to come together and contribute to the same thing. So I'm really, at the end of the day, very lucky and very grateful to be working with all of you. Thank you very much.